SPSS problems in there?
Not in this part. The next couple of sections is going to be pretty much all hand calculations. And when we get to, let's see, module 1 and 2, probably module 3 or 4 is where we'll start bringing in SPSS again.
What is project 2 do? I missed on that one.
I thought it was not Monday.
It is not Monday. It's still TBD. So it'll be a couple weeks after we get back from break. So you'll have a couple of weeks. Because you still have to get the surveys cleaned up, get those approved, go out and collect your data, so it's at least a couple of weeks. How many weeks do we have when we come back from spring break? 6 weeks? So it's more, it'll probably be more like 3 weeks. So I think 3 weeks is probably reasonable for this. Okay? Anything else? So that means I have to start talking about new material. Okay. I think I remember which one I turned on. Okay. So we talked Monday about sampling distribution for p hat. We talked about the normal distribution. We'll talk a little bit more. We'll have a couple of examples to work on today for normal distribution. We need to talk now about confidence intervals for p hat. So we have a portion that we're interested in. We've got our p hat in our sample. And we're going to make a confidence interval then for p. So what is a confidence interval? What does it consist of? Yes, it's an easy question.
I'm probably really wrong, but isn't it like the standard deviation, like divided by the mean or something, or plus?
I'm thinking even simpler than that. Confidence interval is 2 endpoints and an interval between them. Okay? That might be one. But the main thing is we have 2 endpoints, right? Okay? To start with, we have 2 endpoints. We've said that every interval we're going to work with is going to have a center. And what's going to be at that center? P hat? Did I hear an echo? Haley has to speak up louder. Okay, so p hat comes down here. That's the center of our confidence interval. Okay. Now, if we take a little bit of a step back, actually, let's look at it this way. What was this piece right here?
Margin of error.
Margin of error, yeah. So the interval is centered at the estimate. The width is determined by plus or minus the margin of error. And if we write down our template that we had, we said that the intervals, or all of the intervals are estimate, plus or minus, and I'm going to break this up into 2 pieces. We know it's margin of error. Margin of error is broken up into 2 pieces. One piece was standard error, correct? Did I talk about what that other piece was? So what was it?
It was the multiplier that you got from using the empirical rule?
Yep, this is your multiplier. And we know that this is together the margin of error. Okay? Now we just said that this center is p hat, plus or minus. On Monday, we said what the standard error was, didn't we? I seem to recall saying that. Anybody remember? Let's start it this way. One of the things that we're going to start with today is, as we're going through this last part of the semester, we're going to develop a procedure where what we'll do is we'll find from our decision tree, or however else we want to do it here, we're going to follow, in this case, our response would be a categorical variable. That means we go to the left. It's a proportion we're looking at. We have one group of data that we're looking at, so we don't have it broken up into separate groups by anything. That gives us a single proportion. This is what's called Module 1 in your textbook, or case number 1. This is a single proportion analysis. So case 1 is a single proportion. And what I'm going to do is I'm going to start building a table. We're going to put the table up here in pieces as we work with them. But eventually we're going to come together with a full table. It'll have about 6 or 7 rows to it. And it'll have all the pieces, parts that we need to build confidence intervals and to do hypothesis tests for each of the situations that we're working with. Okay? So that's what we're starting with right here. And this is actually kind of a merged form of tables that are already in your textbook at the end of the chapters that we're working on. So I think it's at the end of chapter 10, chapter 12, and probably 11 and 13. So there are tables that they've got all this in. We're going to be building this a little bit as we go. So the first piece is parameter. And the parameter for a single proportion is simply P. That's the value in the population that we're interested in. There is an estimate associated with P. That's our P hat in our sample. On Monday, we determined that there was a standard deviation. This is the standard deviation of the sampling distribution of P hat. So what we found out was that P hat is distributed as a normal with P as its center or mean, and as this standard deviation as the measure of its width. Okay? Then we had a standard error that we talked about. Standard error is simply our best guess at that standard deviation using only things from our sample. So that was the square root of P hat, 1 minus P hat divided by M. Okay? There's another thing that I didn't get to on Monday. I'm not sure why. It's written right on the notes that I was working from. But I missed something on Monday that we talked about during the 1 o'clock, but we missed here. And that was the conditions under which the sampling distribution of P hat is sufficiently normal. Now the first 2 conditions, and these are all in your textbook, the first 2 conditions are conditions which we're going to pretty much say are true in every case. The first is that there actually be a population parameter. So there actually is a proportion that we can look at. In other words, this isn't something that's bouncing all over the place. It's a constant. We could actually have some chance of being able to measure. Okay? Second condition is that we have taken a random sample, or that we have gotten our data from repeated trials. A random sample would be something like we've been talking about, taking a simple random sample. Repeated trials would be like we did a while back when we were doing flipping coins. That would be a repeated trials type situation. So, under those 2 conditions, the last condition is the one that will change from each case, and that is that the sample size is sufficiently large.